Hello, you are listening to Angelneers, the podcast. Angelneers is a Silicon Valley community for upstarts where founders and operators share their firsthand knowledge on how to build and scale startups. I'm your host, Oleg Kuchikov, and our guest today is Chris Surdak. Chris is an award-winning, internationally recognized transformation expert who's leveraged leading-edge technologies such as robotic process automation, artificial intelligence, natural language processing, and blockchain to drive results-oriented digital transformations for organizations of all sizes, industries, and regions. I'm excited to bring Chris on to talk about how businesses should tackle the challenges of elusive success with AI and just learn more about AI in general. Chris, welcome to the show.
Thanks for having me. I hope I can live up to that billing.
This intro gives us a very high-level overview of who you are. Can you take us a little bit into the weeds and kind of tell us more about your background? And you worked in the you worked as a chief transformation officer at the White House. How did you end up there? Give us the highlights.
So with that, I was there only briefly, unfortunately. I frequently say, elections have consequences, but it's from probably the last 15 years of my career where I was heavily focused in the legal world. So even though I started out as an engineer, I do have my law degree and worked a great deal in the world of e-discovery. So the use of things like emails and text messages as evidence in legal proceedings. And so I got tied up into a lot of regulatory issues that were related to that. And if you think of the early 2010s, at that point, social media was still relatively new. It was only a couple years old. We were doing big data back then. We were doing natural language processing. A lot of things that we're starting to take for granted now really started about 10 years ago. And I was really working at the forefront of that. So the project that I was supporting was a very large scale kind of data harvesting and analytics platform that was going to be used between the US and members of NATO just to try to get improved data sharing, intelligence sharing, and intelligence gathering. So getting there was really based upon really the prior decade's work in those spaces, and then also my writing and doing lots of public speaking about those topics.
Let's start with defining AI, and I'm going to ask you to compare it to related concepts like machine learning and automation and robotics. So just start with that definition, please.
Yeah, so people that sell artificial intelligence solutions, quote unquote, generally hate my definition of it. It's because my definition is quite simple. AI is nothing but applied statistics. Really, that's all it is, in effect. And you kind of talk about robotic process automation, machine learning. There's sort of that continuum from rigorous rules-based, it's effectively just software in the world of RPA, up to applying probability and statistics to say, if I'm going to try to solve something where there isn't a hard, fast rule, I want to apply historic information and statistical analysis to try to predict what the correct answer might be in the absence of a rule and in an absence of knowing exactly what I'm going to get. So as it exists today, even in its most advanced forms, it's really, in my view, AI is really nothing but applied statistics. The difference now is we have much greater computing capacity, vastly greater volumes of data to go with. But the tools and stuff that we use today are the same ones that I learned in school 25 years ago. And it's math that was invented half a century ago, at least. Yeah.
And what differentiates other concepts that are related, like machine learning, automation, and robotics?
So robotics, as I said, is very much rules based. If you've done any RPA work, the process is sitting down and writing up all the rules that must be followed. And this is one of the challenges in why RPA projects often fail is no one wants to go through the necessary rigor of figuring out every possible rule that needs to be defined and doing so. It's really an attempt to shortcut basic programming and disciplined software engineering. And when people are surprised that it doesn't work, I say, well, you kind of get what you paid for. Machine learning is, again, it's applied statistics, but the emphasis, in my view, is on the learning part as opposed to the doing part. A lot of people that are doing machine learning are looking for insights, but they're not necessarily generating actions. So if I was going to make a distinction on what makes artificial intelligence different in that continuum, it's that I'm trying to operationalize the insights that are generated, and I want to operationalize it with a degree of independence. Okay, reaching that no human in the loop kind of thing. Otherwise, what's the point? And this is a conversation I had just 2 days ago with Doug Laney, who's very well known in the data and analytics space, where he wrote his book Infonomics. We're talking about the value of data and how do you monetize data, and we share the view that the absolute worst case scenario in analytics is to achieve an insight but not act upon it, because you've absorbed all the cost and all of the effort and all the time it took to get to that insight, but then you don't act upon it. That's literally the worst case scenario. And that's where the vast majority of companies find themselves, quite honestly.
Okay, so to use a metaphor, it's kind of like having something of value, but not using it. Like maybe having $20 in your jeans, but you don't even know about it. You're not going to spend it.
Well, it's very apropos that you use money as the example, because capital as the example is in fact the problem. And this is something I've written about extensively, and it's a topic I cover a great deal in my latest research and upcoming book, Data Diabetes, where our organizations for a quarter of a millennia have operated on the basic ideas of capitalism, which is I use what I call the analog trinity of bureaucracy, processes, and rules to control capital. So, capital, and one of the fundamental truths about capital, at least until recently, is that it goes up in value over time through mere possession, right? And it's fungible. Those are two key concepts. So if I have $1 today in a world with positive interest rates, it's going to be worth $1 and something more a week from now. And I can trade that dollar for other things of value. It's fungible. Here's the problem that we have in most organizations is that we treat information with the same analog trinity: bureaucracy, process, and rules. But information doesn't act like money. It generally loses value with time. So it's imperative that you act upon it quickly. And it's not fungible. A piece of information in one context may be completely valueless, and in another context, it might be the most valuable piece of information that ever existed. So we try to control and manage and govern information the same way we've done with money for 250 years, and it simply doesn't work.
Along those lines, like today's topic is kind of extracting value, right, from AI. Can you talk in just generally, like what areas can organizations achieve value using AI?
So the thing that led me to the premise of my latest work, Data Diabetes, is information in this day and age is a lot like sugar for a diabetic, right? You hunger for more sugar, you have that sensation of thirst, but the more of the sugar you have, the sicker it makes you. And this is what's happening to many organizations today, because most of our businesses, if your business is more than 20 years old, you are trying to digest or metabolize 2020 volumes of information with 1999 business processes. And it simply doesn't work. You simply can't keep up. We're in an age of smartphones and apps and social media and blockchains and so forth, and we're trying to live in that world with Nokia bar phones and dial-up connection processes and technologies or techniques. So the AI success, in my view, is all about increasing an organization's data metabolic rate. So how quickly is information coming into your organization? How quickly can you consume it, digest it, and then do something useful with it, with the emphasis being on that doing something useful. A lot of organizations, if they're doing machine learning, they're trying to get to the insight, and then they stop when they generate the report. or they view, we generated the PowerPoint, we've achieved some degree of success. No. If you're not doing something different as a result of that analytic work and the result of digesting that data, then what was the point? So the organizations that I see successful with AI are recognize that driving for action from the investment that you're making, and an understanding that you need to let go of some of the bureaucratic and decision-making control that is very much inherent in most of our organizations today. The AI should be sufficiently governed and adequately trained with oversight, but it should be making decisions on our behalf with us monitoring what it's doing. Otherwise, it's not likely to generate any positive value whatsoever.
Okay. So we want to tie our AI to action somehow.
Yes.
This all kind of starts with, and thank you for the explanation. This all kind of starts with data. So I kind of want to go back to data to the beginning, right? Businesses should be treating data as a valuable asset. That should be the priority in any of these businesses that are implementing AI or trying to use AI. What kind of data should these organizations be looking for? Like, what's the difference between good data, quote unquote, and bad data for organizations? Like, what's going to lead to this data diabetes that you're writing about versus, successful outcomes from implementing AI?
So in my view, there is no bad data. There's just bad questions. And I say that from seeing organizations literally make this mistake. A lot of organizations have their ETL processes, right? So extract, transform, and load, or basically data cleansing. And I've always been adamantly against the notion of data cleansing because bad data, quote unquote, is it for one. Bad data that's noise for one particular question is actually likely the answer to a different question. And so if you strip that away, you strip away your ability to answer that question. So you need to understand what you're trying to achieve with the data first, and then you can start making qualitative evaluations of that data. It's back to what I said a moment ago, where the context is absolutely critical in understanding the value of what you're looking at. The example I give is many years ago, I was working with a cable company that was losing subscribers, and they wanted to analyze why that happened. And one of the things they did in the cleanup is they would have they'd have all their customer records, and they would have duplicates. And what they found is that with some duplicates, there was a phone number. It was identical, but in one instance, the customer information had a phone number field that had a phone number in it. And in another record, there wouldn't be a phone number. And so they're in their process of cleaning, quote unquote, the data, they just eliminated any of the duplicates where the phone number field was blank. When in fact, what that blank phone number told you is that was the account, that was the person that dropped their service with you. So in the process of supposedly cleaning up the data, they actually eliminated the answer to the very question they were trying to answer. And you find that unintended consequence more and more often, because people don't anticipate the other potential use cases or questions that a given set of data can answer. Now, what brings us as a challenge, just to complete a thought, what makes this deeply challenging in AI is that in AI, the value of your AI and the results it's generated is completely dependent upon the quality of the data you feed it. It is no smarter than the information you provide it. And so both the cleansing of data and the introduction, whenever I do something wrong, quote unquote, with my data and I put it into an AI, the AI will grossly emphasize that mistake and or error and or bias. Now you can use that for good, but generally speaking, it often leads to bad results.
What constitutes quality data? I guess everything's context dependent, right? Every good question, the answer is it depends.
It entirely depends on the question, and it entirely depends on the context with which the question's asked. And that's a level of analysis that most people haven't had to bother with so far. And so that's partially what leads to the relatively low success rate. Is software and data and analytics is complicated enough, but when you need to think of the problem and all those additional dimensions, for many people it gets overwhelming.
Yeah, I'm a little overwhelmed as we speak. How do you do it? Like, how do you ask those questions? What kind of questions are you? What should you be asking?
Yeah, so at the beginning of my career, I got a cheat code. I actually started my career as a spacecraft systems engineer with Lockheed Martin, and so if you wanted to send a spacecraft to Mars, you needed to know literally you had to think of every possible scenario of what it took to get there. You had to calculate the potential gravity effect of Jupiter and Saturn, even though they're billions of miles away. And most of my time there, I worked on engineering failure review. So we had 3 major spacecraft failures over the course of about a year and a half. And all we had was the data that came back from the spacecraft. And we had 100 engineers who had to reverse engineer what made the spacecraft fail based upon just the data. And it would take months, and you would eliminate all the possible reasons why it didn't, so that you would fall upon the reason it did. So that sort of engineering rigor, and that consideration of all possible outcomes and all possible inputs. I started my career that way, and it ruined me as a software guy for the rest of my life. But now I find that is one of those determining factors that makes an AI sort of project either succeed or fail, because you're being that thorough.
Yeah. Really interesting. I'm going to slightly pivot to ML ops practices. Can you just define that for me? Because before today, I didn't even know what ML ops was.
And most people don't. I mean, in some ways, it's just the next. It's just a marketing buzzword for systems engineering. And I was thinking through that before, because I knew you wanted to address this. This is exactly what we did when we were building spacecraft. At the beginning of the space era, you'd have a team of engineers that literally built like every part of the spacecraft. They knew every part of it, because the spacecraft themselves were relatively simple. As you wanted to do more complex things, like go to other planets or land on other planets, the spacecraft itself inherently had to get much more complex. And to digest that complexity, you needed to break the spacecraft into its subsystems. So you would have a propulsion subsystem, you would have a communication subsystem, a guidance subsystem, and it's an important thing to recognize. You don't reduce the complexity of the problem, but you make that complexity more comprehensible, if that makes sense. Mm-hmm. So this team worked on one subsystem, this other team worked on another subsystem, and you needed to have some engineers over all of them that put all those subsystems together. That's the role that I generally played. So in ML ops, what we're trying to do, I think, is that same systems engineering approach, which is saying, as we try to do more and more complex things with ML and artificial intelligence, we need to break that complexity down into components so that we can properly address the level of complexity. It's important that we don't confuse that with making it simpler, because we're not making it simpler. We're only making it more comprehensible, if that makes sense.
Mm-hmm. Yeah, you're partitioning. You're not making it less complex.
And it leads me to, there's 2 laws in coding. One is Tesler's law of conservation of complexity, where the level of complexity in doing something, you can't reduce it. You can just kind of shift it either to the user or to the computation. And then there's Ashby's law of requisite variety, which basically says the answer to any problem has to be at least as complex as the problem. Right? And that's kind of math. If you have 3 variables, you need 3 equations to solve 3 variables. You can't do it with less. And a lot of what we do in this space, particularly in RPA, but I also see it a great deal in ML and AI, is we try to pretend there's less complexity there than there really is. And that can work in average use cases. But as soon as you fall out of the average use case and something unexpected happens, that's how you get a Chernobyl. That's how you get a Fukushima. That's how you get a shuttle disaster. That's when things get really ugly really quickly in otherwise unanticipated ways.
Yep. Well, you're making it an easy transition to the next question, because these complex systems and systems made up of systems where you have to consider every possibility. We'll never be able to do that, right? We'll never be able to actually consider everything that's possible, but we have to try. And moving these AI models from, say, the research lab into, the consumer world is definitely not an easy task, and you're going to run into all sorts of complexity. So what do you need to consider as a business that's like trying to use AI when you're starting this journey, other than, of course, what you mentioned earlier, which is what kind of outcomes are we trying to do? How do you mitigate those risks of the wheels hitting the pavement and using this stuff in the real world?
So there's 2 dominant things that I find are critical and that the vast majority of people don't do. The first is engineering of your input data. So if these things are nothing but statistical engines, and the statistics that they operate off of is based upon the data that you feed it. initially, right? So if I'm doing a neural network, I'm going to feed it a bunch of information. All the nodes, come up with their relative values based upon that information, and then you implement it. The problem with that is the vast majority of data that we use is normal and or normalized data. It follows a normal distribution curve. Well, what that tells you is you're gonna give the statistical engine 10 million data points, and like 8 million of those data points are going to be close to the average value. So you're going to teach the ML or the artificial intelligence, here's what you do most of the time when things are average. Great. Well, I mean, did I really need help with that anyway? Because I should know what my average response to an average input is anyway. It's when you have an extreme out of normal sort of event that takes place that the potential for error occurs. And if I've used normalized data to train the AI, those endpoints, those rare cases, those black swan kind of events are the least amount of data that I've shown it. So I'm giving it the least amount of statistical guidance on what to do when the unexpected occurs. Do you follow?
Mm-hmm.
So what we realistically need to do is invert the data that we train with. We need to have anti-normalized data. We need to overemphasize the endpoints that are unlikely to happen so that there's strong training in the system of what to do when the unexpected does occur. And I need a lot less data about what to do when something normal happens because normal is normal. So in most instances, we are literally training our AIs with exactly the wrong kind of data. And by doing so, we're embrittling the work that they do. And that leads to the second concept, which again comes from my spacecraft days, and that is designing to fail gracefully. So if the AI does something really screwed up, have you designed the system so that it can fail safe? And the best example I have of that is one of the Apollo missions, the rockets that helped us land on the moon. At one point, there's 5 engines on the stage, and 2 of the engines shut down. Itself an interesting story. The reason 2 shut down is that one of the engines actually shut down, but because the engines were miswired, when they commanded that engine to shut off, they actually shut off another one on top of that. So wiring errors are a big mistake. Even though it lost 2/5 of its total propulsion, the other 3 engines were enough to get it into orbit, so it made it. Switch forward 20 some years, and you go to the space shuttle, you had an engine failure, catastrophic, astronauts died. And that's because NASA when NASA was going for the Apollo launch, they recognized the level of complexity and they designed for that kind of resilience. Whereas the space shuttle was designed much more with a kind of bureaucratic, cost-cutting, try to make it repeatable. It was just a different focus, and it showed in the results.
So the difference might have been, we're not doing this for the first time. We don't have to take the same mitigation steps because it's been done before.
There's a significant amount of intellectual arrogance that ties with a lot of these leading edge technologies, which is the nature of leading edge technologies. So early in my career, I learned a degree of humbleness in the face of the technologies we have at our fingertips.
What aspects of operating artificial intelligence are different from operating software? I think you mentioned earlier AI is like essentially a type of software. I don't know if that's correct or not, but yeah, what's kind of the difference between operating using AI versus just software in general?
So this one's a little bit more nuanced. I think other than the upgrade paths and the sort of dev that we do on software, so we're constantly upgrading it. The underlying elements of a software package or an app or whatever generally don't change. Whereas with artificial intelligence, if I'm doing it correctly, it should drift. It should change itself. It's sort of a Heisenberg uncertainty principle thing. The act of measuring something changes what's being measured. Well, if you're getting AI right, the act of automating something should be changing what's being automated. And if you didn't cause a change to the underlying process that you're trying to attack with AI, what was the point of the AI? This is one of the challenges that comes up a lot in the world of RPA, where people will automate a particular step of a process, but because that step was automated in isolation, there's no benefit. Maybe you get the step done in 1/10 of the time, which is very typical in RPA. But because none of that benefit goes upstream or downstream from that process step, it's like a tree falling in the forest and no one heard it. Did it really fall? Right? If I'm automating a step of a process and there's no upstream or downstream effect, what was the point of automating it? And you get that a lot. Um, so with AI, the key with operationalizing AI and getting any benefit out of it is expecting, anticipating, and ensuring that you've caused an instability or some sort of dislocation in the thing that you're applying the AI to.
It's interesting because the AI, the way the I guess AI models versus like, software that you wrote, right? Software is just like a list of instructions that a computer's going to carry out. There's a difference, right? There's like one is very repetitive, the other one you're saying you're expecting some measure of uncertainty. And it really makes, I don't know if this is related, but it really makes me think of those like robots that they can't really train to walk, they can train them to jump real high, or you can make a machine feel like an elbow, and it can be 100 times more powerful, but you can't get the thing to just like walk in a straight line.
Yeah. Well, it's the difference between following rules and then, following probabilities. Hence, it's just a statistical engine. So, and in fact, a lot of organizations are trying to use AI to replace rules-based software, and it's both a waste, and it's arguably going to cause more problems than it solves. Right? If I can manage something by following a rule, that's the way to do it. It's when uncertainty comes into the equation that I need to apply the probabilistic mechanisms and tools like AI, and then that's all well and good until my best guesses are wrong. And so, what do you do when your best guess is wrong? That's the hard part. That's the engineering part.
The fail gracefully, I think you called it.
Failing gracefully. Don't have a Fukushima. Don't have a 3 Mile Island. Don't have a Chernobyl. Every one of those instances, you had thousands of engineers that did the absolute best that they could to design the best system that they could, and that those best efforts were overwhelmed by complexity. And the more complex the problems that we try to address with these technologies, the more disastrous the results will likely be when we get it wrong, necessarily.
That makes sense. So now that AI models are playing, increasingly important roles in daily decision making in many organizations, I guess we just talked about what the risks are, but what are the risks that these models pose, and what steps can be considered to mitigate, the risks that we're talking about?
Well, it's all, again, it's contextual. It's what are you using it for? And what is the worst case scenario of what happens if it goes horribly wrong? And one of the things that we use throughout my career, for sure, but it really came to light when I was working with the American Red Cross on the software that was used to manage the nation's blood supply from blood donors and so forth. And this was in the mid 90s when HIV was big and everyone was worried about it. And so we were doing HIV testing of all the blood that was collected in the US. And obviously they still do that. The challenge was this: if you have a false positive in that test, so you got someone's blood, you tested it, and it came back as a positive, positive for HIV, but it was incorrect. So false positive. You then had to tell that person that they had HIV, but they didn't. Now, that's a bad day, but it's not a catastrophic result. A false negative is the person had HIV, they didn't test positive for it, and you don't tell them. That's a catastrophic result. And the same was true in my spacecraft days. So, we would say a false positive costs money, a false negative costs lives. And so you actually need to design, back to the data engineering, you need to design data that reflects both a false positive result and a false negative result for whatever your AI is analyzing, and then confirm that the AI understands here's a false negative and here's a false positive. It's never going to do it 100%, but the more you proactively train the AI in that way, the more likely it is it's going to see it and be able to prevent it. So you're talking about, how do businesses succeed with AI? In 10 seconds, I can ask a company that has an AI project. I can assess whether they are part of the 95% of projects that fail or the 5% of projects that succeed. And I can do it by asking one question. You want to know what it is?
Yeah, what's that?
What percentage of your total budget for this AI initiative or machine learning initiative is dedicated to software and technology and tools versus what percentage is dedicated to the shaping and procurement and engineering of the data that you're training with? If the proportion of the budget dedicated to the shaping of the data is less than 50%, if it's less than what we're spending on the software, you're going to fail. You're going to be part of the 95% of projects that fail. It's that easy. Yeah, you show me one budget number and I'll tell you whether you're succeed or not.
I remember not to digress, I had a professor in college. He said this thing that really blew my mind. It's like the best thing you can do for your programming is not program.
Elon Musk is famous for saying the best part is no part.
Okay, so next, like, how do we trust AI, right? These tools are made. You don't, right? Exactly.
Well, if you think back to our last half-hour conversation, I think back to Ronald Reagan with the strategic nuclear talks. Trust but verify, right? You don't trust it. You need to anticipate how it could go wrong, what might happen when it does go wrong, and then you need to train it what is wrong, which is that false positive, false negative thing we just talked about. And overemphasizing the extremes of the normal distribution, not the middle of the normal distribution. Those are all ways in which we are building a trustworthy AI. Blindly trusting AI is just a recipe for disaster. So you have to assume it's kind of like raising kids. I have 3 kids. I mean, you train for the worst and hope for the best.
Oh, that was great. So, okay, a better question would have been maybe how do you build trust in AI versus flat out trust AI?
With all the things we just mentioned, right? I mean, I'm sort of giving you guys the keys to the kingdom on where I've seen projects both succeed and fail. And it's these sorts of things. It's the data shaping and engineering. It's understanding the question you're trying to answer in all of its dimensions. That multidimensionality is critical, and not having sort of the intellectual arrogance to say, "Well, this should be simple. Let's make it simple." No, that simplicity is an illusion that will come back and bite you at some point. It should be hard.
It should be hard. Along the lines of intellectual arrogance, like, we all have mental models, we all have, hardwired behaviors and whatnot. We all have bias, right? How do we reduce the impact of our biases when we're building, AI solutions? Is it be humble?
You have to embrace those biases. You have to be humble. You have to be honest about them. I've written about this recently quite a bit, and it's something. This is one of the things that, as a data engineer and data guy, it led me to get my law degree later on, because all of the real problems that we were having with the technology had nothing to do with the technology. It had to do with people and ethics and stuff like that. Understanding that the bias is always going to be there, and also understanding that it's the nature of AI and ML and statistics that any bias that exists is going to be overemphasized in the results. And that's something that's been proven time and again by organizations. I don't know if you know that, like the Wells Fargo kind of mythical example of one branch of Wells Fargo had some very heavy racial bias in their approval of mortgages, and it was limited to one branch in one city, so forth. And that small set of the data representing a fraction of a % of the total data that they use, but that poisoned the entire well of the resulting AI that they built, such that the resulting AI refused to approve a mortgage for any person of that race, regardless of their income or credit rating or anything. So it is critically important to be very humble about the fact that the bias is there, that it needs to be, you need to design, again, it's a false positive, false negative thing. You need to design in biased data in your data set and then teach the AI, hey, this is what bias looks like. If you don't do that, it'll find it and it'll emphasize it by orders of magnitude.
So given that these things are going to make mistakes, how do we build transparency into these AI models, which are, for the most part, people treat them like black boxes? How do we kind of make those black boxes a little more transparent so we can do what you were doing at Lockheed, right? Do the disaster impact.
Well, yeah, basically, I mean, it was failure review. The Again, it's the shaping of the data that you use to train it with. Um, Particularly in a neural network, I mean, it is very much a black box for sure. I mean, you have the different layers in the neural network, and you don't necessarily understand how it gets trained. Only that it gets trained, and you can spend at least as much time or even more time trying to dissect how the training progressed than in performing the actual training. It can be a significant loss leader. The way that I think you get around that is, as I've said, you need to design in the disaster cases and the worst case scenarios and so forth in your training data. And then when you feed that in those worst case scenarios through the machine, are you getting the expected results? Okay, or what results are you getting? Because that tells you, back to that, the noise for one question is the signal for another. Well, in that instance, what looks like noise is actually the signal that, like at 3 Mile Island. I visited the control room when I was in high school, way a long time ago, and they showed us the one light. It was a red light that had they seen that light blinking, they would have known what the actual failure was. That the one cooling loop had was stuck open, but that one light was like 6 rows back in a room filled with computers. And at the very front of the room was like 6,000 dials and lights, and they were all blinking at the same time. There's no way anyone would have thought to go back there and look and see if that one light was on. So the failure, it was one of those things that was obvious after the fact, but only after the fact. And so you need to anticipate those sorts of scenarios so that you can prepare for them. And that's what I found in all the spacecraft the accidents or explosions or whatever that occurred. After the fact, we could always find what went wrong and what we missed. And that's back to that idea, false positives cost money, false negatives cost lives. That's where that comes from. So the reason we did those after action analyses is so that we could learn from it and do better the next time around, hopefully.
Gotcha. Great answer. So today, it's 2023. A lot of companies, everyone's talking about AI, right? A lot of companies realize that they have to, or that they should be investing in AI solutions as soon as possible or risk falling behind their competition. The question is how to do that successfully. And I think we've talked about that a little bit today. I guess what I've learned so far is, start by having some idea of the outcomes you're trying to achieve and go from there. Is there a blueprint? Obviously, again, every good engineering question comes down to it depends on the context, but is there a blueprint for successfully implementing AI solutions in existing businesses, or is it just going to be too complex for an answer?
No, there's a few, I think, fundamental things that you have to have in mind if you're going. The 5% that I see succeed have a certain set of frameworks or things that they follow. The first is if it was easy, you should have already done it. So expect this to be difficult, expect it to be hard, expect it to be expensive. The other one is I have a lot of organizations where they'll go with the low bidder, whether they're hiring talent or they're buying software or whatever. And the question I always ask them, are you trying to succeed or are you trying to fail as cheaply as possible? So if you're having these sort of budgetary, we always used to say at NASA, it was amazing the space shuttle ever worked because the whole thing was built by the low bidder. And if you're doing something truly disruptive and complex, the low bidder probably has no idea what it is you're actually trying to do. So it should be expensive. It should be complicated. It should be difficult. And it should be hard to find people that actually know how to do this. I can legitimately say I used to be a rocket scientist and I can barely keep up with a lot of the math that we're using now. So, I kind of have that Dunning-Kruger thing going on where I know just enough to know how little I actually know. So it should be tough and expect it to be so. And then just from, again, what the difference between machine learning and AI in my mind is that you're operationalizing the results. You're actually doing something with it. And a good rule of thumb that I've used for the past decade in that space is whatever process you are trying to attack with AI, you should expect the cycle time of every aspect of that process to be cut in half at least every year, if not faster. In the information age, the basic denominator in the equation of value is time. It's not money anymore. So I don't care about return on investment, return on money. I care about return on time. And so AI should be feeding that need for an increase in your the metabolic rate of your organization, a dramatic increase in the metabolic rate of your organization. And this again ties back to data diabetes. Organizations, you give them more data, they tend to slow their decision making process, not speeding it up, which is another sign of being data diabetic.
Why is success with AI so elusive? I know we've talked about a lot of interesting things today. People lack humility. People underestimate the complexity, or they misunderstand the complexity. There's probably a million things to point to, but what can you say about that? Why is success with this stuff, which is clearly valuable, right? Clearly, it can do amazing things. It could also make a lot of mistakes, but it does amazing things. Why is success so elusive for organizations?
There's a heck of a lot of Me Tooism in this. So whether it's AI or RPA or blockchain, I work with executives all over the world, and a lot of these technologies are what I call FTDs, fairway transmitted diseases, which is one CEO will talk to another CEO while they're playing golf. Hey, I have a blockchain, and he'll say, well, I have two blockchains, so I have a spare. They have no idea what the technology is, what it does, or how it's useful. They just want to say that they have it, and I'm being a bit flip to a certain extent, but it's not too far from the truth in a lot of instances. Organizations need to explore these things, but they need serious people that have serious knowledge in how to operate these things and make them valuable. And by their very nature, those people are rare. I've done a lot of presentations and talking over the years on how all this technology is going to change the nature of work and employment. And I wrote an article back in 2014 called "Better Be a Baller," which is basically baller like a footballer, soccer player. Where the top one, this technology is going to be a place where the top 1% are going to be compensated like professional athletes, where the top 1% are going to get millions of dollars and be in massive demand. And if you're, outside of the top 1 or 2%, you'll be parking cars if you're lucky. And why is that? Well, these technologies can take can take human thinking and lever it by a factor of 1,000 or 10,000. Well, if I'm going to take an intellect and multiply it by a factor of 1,000, I want the person with 160 IQ, not a person with a 90 IQ. As a rough example, I'm going to multiply. I got to multiply the very best, and if I use anyone less than that, I'm getting like geometrically worse results. I used to work at Citibank. We had 10,000 loan officers, and we were looking at automating the whole loan approval process. And this was in 1997. And back then we realized I don't want to see how I want to get the data on the best 5 loan officers out of that 10,000. The other 9,995 will give me less good results. I don't want to replicate them. I want to replicate like my best 5, so there's a little variety. But otherwise, everyone else is only going to give me worse results, and in a magnified way. So this makes a huge change in the definition of talent, the acquisition and retention of talent. Like 95% of the workforce globally is looking for a new job right now. 80% plus have quiet quit. And then Chat GTP. I was sharing a discussion with some of my colleagues the other day. It's going to be flooding the market with mediocrity. Yeah. Chat GTP can pass the medical boards with a B. So it sucks if you're an average doctor because you can be replaced now. But the A+ doctor is going to be more valuable than ever before in a world with technologies like that.
That's really interesting. Along the lines of talent, should companies be prioritizing recruiting talent from the outside or growing it and training it internally? What do you think the winning solution there is?
I think they need a healthy balance of both. The likelihood that Joe Schmo company, Fortune 500 company has a world-class AI expert on staff right now is probably pretty low. It's probably exceptionally low. But what they do have is people that know their internal processes, their people, how they operate intimately. And arguably, once you have enough technical expertise, which is literally like one person, two people, it's that tribal native knowledge about your organization, your business, and how you operate that's far more important. So bring one or two, maybe top technical people from the outside in, and you're going to pay through the nose to get them and keep them. But then you want the people that understand your brand, your organization, your culture, to answer all of the questions that the technical person is going to have to answer.
And to build on that, what kind of steps can companies take to attract that top talent and then retain it?
Oh, geez. I mean, obviously, money is a key piece of it, but those folks want a degree of independence, a degree of authority over what they're doing, and a sense that they're making a difference. Again, I wrote about this a lot, the 6 new normals in my second book, where everyone wants money and so forth, but two of the things that people most hunger in this world, and because we're all addicted to our phones and so forth, is a sense of purpose and a sense of belonging, intimacy. So intimacy and purpose. So give them, if you want someone to come on board, you got to be working on something compelling, something meaningful, something that allows them to demonstrate that they're having an impact on the world, and something that helps them grow. And those are conversations that most people in HR, they can have very superficially, but they don't really mean it. But that's the difference between getting and retaining people of that caliber.
Well, I didn't think we'd be talking about purpose, humility, and such human things in the AI podcast.
I had someone ask me a couple of weeks ago, what classes I would recommend for starting an AI program at a university, and they specifically said, what technologies should we teach? And I said, I don't care what technologies you teach, because the technologies change every 2 or 3 years. But I strongly urge you have a couple of classes on philosophy and ethics.
Those things. Darn, this is a brilliant interview. All right, let's wrap it up. Looking back at your career, what's one of the most important things that you've learned across all those organizations? Or if you want to change the question slightly, like which one of those experiences taught you something invaluable?
I've written about this recently too. One of the things, because I was working in the space of natural language processing, so trying to understand language, and particularly how that pertained to the legal field. So going through things like emails and so forth, looking for evidence. And along the way, I actually invented an algorithm, a lie detection algorithm, that every time we used it, it proved 100% effective, could instantaneously detect when someone was lying, who they were lying to, and what they were lying about. And we actually did demos for 3 different clients, and who I'm convinced they didn't think it would actually work. And when we showed them that it did work, they immediately shut down the projects because it was too intimidating. And that was about 7 years ago. So the state of the art today has got to be dramatically better than that. I worked on a project for redoing the regulations for retaining records in companies, the federal rules for how long you had to keep stuff. And it was part of an organization called the Sedona Group, Sedona Conference. We rewrote the law that was enacted in December of 2015. And in part, we changed one word in the federal law. And that one word changed literally all the requirements that companies had for how much information to retain and how long they had to retain it. And that was in 2015. And to this day, almost no companies have acted upon that change. They still follow a policy of keep everything forever. And in October of last year, the FTC started applying personal penalties to executives of organizations that were retaining information on their customers too long and putting it at cyber risk. That's never happened before. And so by changing one word in a regulation 8 years ago, companies are now facing a desperate need to change their data retention policies and how they govern it and everything. It just struck me how powerful changing just one word or one requirement can fundamentally change the operations of every single organization that operates in the United States.
It sounds like a one-line fix in programming more than real life. What was the one word you changed? Can you expand on that?
So the way the wording of the regulation used to be, if you deleted a piece of information on purpose and on purpose or with malice. So the fundamental word was or. So in the legal terms, malice means that you meant to do harm. So I deleted a record because it was going to make me look bad and it would prevent someone from filing a lawsuit against me. So that was the intent of the malice. So the word used to be or. So if you deleted it on purpose or with the intent of causing harm to someone, then you violated the law. We changed that or to and. And so it was if you did it on purpose and you meant to cause harm to someone, then you did something wrong. The distinction is if you deleted it on purpose because you just didn't want it anymore, but there was no malice behind it, you were good to go. So changing from or to and fundamentally changed the information retention policies requirements of every organization in America, and almost nobody responded to it. Unintended consequences, I think, is probably the ongoing theme in my career, and the need to anticipate them even though they're unanticipatable.
Yeah, another very human challenge in AI.
It's never about the technology. It's always about people.
All right, last question here is something I've been holding on to since the beginning. What's harder, a law degree or a degree in engineering?
So that's a funny one. They're both difficult in different ways. And what really screwed me up is the order. Engineering school was awful. I hated it. It was atrocious. I mean, the math. Yeah, I've done math my whole career, and I really never liked it. But it was a means to an end. But it's extremely difficult, no question. Law was difficult because I came at it as an engineer. And the best example, the hardest class in law school, everyone pretty much agrees, is evidence. And that's because there's a rule of evidence. And then that rule has 73 exceptions. And as an engineer, I said, any rule with 73 exceptions isn't a rule. It's not even a suggestion. But you had to memorize all 73 exceptions to the rule. And that's, why these people make $800 an hour. So I would say they were equally difficult in different ways. And the fact that I was an engineer first and then got my law degree made it kind of a lot harder to stomach.
Before we get out of here, what is the best way for our listeners to maybe reach you? And if you have any calls to action, you'd like them to check out a book, something you're writing?
Yeah, I kind of went quiet for a while on social media and so forth, but I post a lot on LinkedIn. I have columns that I write for Get Abstract online and also European Business Review magazine, so you can check those out. You want to reach out to me, you can find me on LinkedIn or just chris@surdak.com. Nice and easy to catch me there. And I always welcome inquiries, questions, whatever. Happy to interact with the community and share what I think I've earned the hard way in a lot of instances. So by all means, reach out.
Please do. I mean, what a resource. Chris, thank you. This was an awesome learning experience for me. I won't be forgetting this anytime soon. Thank you for joining the show. We appreciate your time.
Yeah, absolutely. Anytime.